All right, solving absolute value equations and inequalities. All right. In the middle, what we're going to do is I'm just going to write in a basic statement. Hopefully my pen's going to work decent for us. If I give you the absolute value of x equals 3. What we need to realize when we take the absolute value of anything, it's always going to make it positive. So I need to understand what can I substitute into here that when I make it positive, it's going to become 3. Hopefully we realize it's a 3 and a negative 3. The absolute value of 3 is also 3. Negative 3, absolute value is also 3. Okay, so we got 2. So we're after 2 answers every time. So what we're going to do, once we get our absolute value by itself, unlike this one, I'm going to write 2 inequalities. I want to know when this statement right here is going to equal a positive 12. Because if it equals a positive 12, I take the absolute value, I get the answer I want. I also want to know when this statement equals a negative 12. Because if it equals a negative 12, it also gives me the answer I want. So that's where we're going to get 2 equations from. We're going to take what's inside the absolute value, write it twice. I'm going to set it equal to 12 and then the opposite of 12. I'm going to solve both. And I'm going to get 2 answers. What we want to do is check both of them. Going back all the way to the top. 2 times 8 is 16. Minus 4 is the absolute value of 12, which is 12, so we're good. 2 times negative 4 is negative 8. Minus 4 is a negative 12. The absolute value of that is 12, so both these answers work. We have to check to make sure they work. For number 2, we can't write our 2 statements. We can't write both of these until I get my absolute value by itself. So I'm going to move the numbers away. I'm going to add a 5. I'm going to divide by 3. Now I have my absolute value alone, and that's when I'm going to write my 2 equations. Don't change the left side. I'm going to set it equal to 5. And then I'm going to set it equal to a negative 5. This gets written twice, and I do a plus or minus on the right side. Solve. I get 3 halves. Solve. I get negative 1. That's the math behind it. So next, we're going to take both of these, substitute them into the original problem, do the math, and see if you get a true statement. They're both going to work this time. So we're going to say both of those are my answers, but they're not always both going to work, but we want to check them. So once you get the absolute value alone, write 2 equations. Equal to 12 and negative 12. Equal to 5 and equal to negative 5. All right, the next one. Same idea. I have the absolute value alone, so I'm going to write 2 equations. The first one is going to be set equal to 2x minus 10. The second one is going to be set equal to the negative 2x minus 10. I want the opposite of it, so I'm going to put it in parentheses, put a negative on the outside. All right. Now we're going to solve both. I'll subtract an x, add a 10, I get x equal 12. Over here, on the second one, I'm going to distribute that negative sign and solve. Doesn't matter which way you move stuff, as long as you move and do the math correctly. So I get 12 and 8/3. Now I'm going to check. Absolute value of 12 plus 2 equals 2 times 12 minus 10. Absolute value of 14 equals 24 minus 10. 14 equals 14. As I go through this, if I'm going fast, pause it. Give yourself some time. All right, the next one. This one I would not expect you to do by hand, but I'll do it anyway. I'm going to get common denominators. Like I said, this on a test or a quiz will be a little bit easier to check. And I get 14/3 equals a negative 14/3. This one was 14 equals 14, so it's good. But over here on the right, these don't equal each other. And that's going to happen if this does not work. When I plug this in up here, I do not get a true statement, so I'm going to get rid of that answer, and I only have one answer for this problem. And that will happen. That's why we check that. All right, so, the next part. Absolute value inequalities. We are still going to write two inequalities, but the difference is going to be we're going to add a word between them. So if I have a basic statement, the absolute value of something is greater than k. We're going to need to write two inequalities. The first inequality is just as it is. X is greater than k. The second one, we're going to do like the opposite of both of these. Instead of greater than, I'm going to change it to less than. Instead of k, I'm going to make it negative k. So when it's an inequation, we only change the k. As an inequality, we're going to change that also. We just need to memorize and know when I have an absolute value greater than for my absolute value inequality, it's an or statement. The way I remember, I'm going to read that as a great or symbol. Absolute value of x is great or than k. X is greater than k. X is less than a negative k. All right, I'll show you what's happening in a second. All right, when it's a less than symbol, I'm going to think of it as a less than. Less than makes it an and statement. X is less than k. X is greater than negative k. So we have to write it twice, change your inequality and your sign on the right on the second one. All right, so for number 4, absolute value of 3x plus 6 is greater than or equal to 12. Writing my two inequalities, I'm going to go 3x plus 6 on both of them. The first one is as it is, greater than or equal to 12. The second one, I'm going to switch it to less than or equal to a negative 12. Now, this is where kind of the new part comes in. That's a greater or than or equal to symbol. So I'm going to put the word or between them, which means when I graph them, I'm looking for every possible answer I can get. That kind of goes back to the last section we did. An or statement only has to satisfy one, so we want as much as we can get. So I'm going to solve. X will be greater than or equal to 2, or subtract a 6, divide by 3. I get x is less than or equal to negative 6. So hopefully, once we write this statement here, we should be able to solve it. So now to graph this, I'm going to go negative 6, 2, close circle to the right above 2, close circle to the left above 6. what I need to find are all the values of x that'll make one of these true. All right, so if I pick a number here on the left, it's going to make x is less or equal to negative 6 true. If I pick a number in the middle, like 0, won't work on either. And on the right is going to work on greater than or equal to 2. So I need, change that circle, all of those. When it's an or statement, you give me as much as you can get. And that's our final answer right here. All this work kind of leads us to get there. So write two inequalities, one with the symbol as it is in the number, the other as you make it change your symbol and change your sign. All right, so same idea. I'm going to get the absolute value allowed. Absolute value of 2x plus 6 is less than 8. I'm going to write 2x plus 6 is less than 8, just as it is. The 2x plus 6 is greater than the negative 8. This time, I have a less than symbol, so I put and in the middle. And solve. I get x is less than 1 and x is greater than negative 7. I'm going to graph both as a review of the previous section. Because this is an and statement, I need where they intersect. I need this area here. So above it, where they intersect, I'm going to draw it one more time, just the numbers that work in both. Check it, circle it, highlight it somehow. Tell me that you know what this means and what you get for an answer. All right, we'll do one more, I believe. Yep, one more. All right, so let's isolate the absolute value. Divide by negative 2. Because I divided by a negative, I switch my inequality to negative 11. So I get an absolute value of x plus 4 is greater than negative 11. So I'm going to say x plus 4 is greater than negative 11, just as it is. Great, or x plus 4 is less than a positive 11, which is the opposite. Solve. I get x is greater than negative 15. Or x is less than 7. I'm going to come over here. All right, so, went quick, pause it when you need to. This is what I get. Now, for an or statement, I need to know the areas that will satisfy at least one. Over here on the left, satisfies x is less than 7. In the middle, it works at both. On the right, x is greater than negative 15. So for this one, since all my numbers are satisfied, I can pick anything I want. We're going to say this one has all real numbers. Every value of x you substitute into this is going to work. 0, negative 84, 73, 25. No matter what you pick, it's going to work. All right, so that's the section. We're going to go back to here. Once we did this first step, we should have been able to stop if we thought about it. All right, there's a lot of times when we get answers, we need to go back and make sure it makes sense. All right, so I have the absolute value of x plus 4 is greater than negative 11. The reason I say we can stop is because if we think, whenever we take an absolute value, no matter what I plug into here, my final answer is going to be positive. Every time. If I have a negative number on the inside, it becomes positive. A positive number becomes positive. So tell me, when is a positive number going to be greater than negative 11? And that's going to be always. No matter what we plug into this, when we take the absolute value of it, it becomes a positive answer. And a positive is always greater than a negative. That's why it's all real numbers. All right, so I hope that helps. If you have any questions, please contact me somehow. Let me know what's going on. If you need any help, please do so. If not, I will see you in class on the next day.